In this video, we will talk about how to write an absolute value as a piecewise function. So as an example, if we consider the absolute value of 4, that would be equal to 4. But the absolute value of negative 4 is also equal to 4. Now, if we wanted to generalize this, we could say the absolute value of x, some number x, is equal to x. But the absolute value of negative x is also equal to x. Now, if we wanted to write the absolute value of x as a piecewise function, here's what it would look like. We could say if the value provided to x, if x is greater than or equal to 0, then the absolute value bars, they just return x. But if x is less than 0, in other words, we provide a negative value right here, in order for us to get a positive x, or if we put in a negative 4 right here, in order for us to get a positive 4, we would need to multiply by a negative, because a negative 4 is a positive 4. So in other words, if we provide a negative value, we need to multiply that x by a negative sign. So this is how we could write the absolute value of x as a piecewise function. So this is kind of our general form that we can use. So with that in mind, let's check out a couple more examples. Alright, so I've rewritten the general form that we can use when we're rewriting an absolute value equation as a piecewise function. So knowing this, let's consider the function f of x is equal to the absolute value of x plus 5. How could we rewrite this function as a piecewise function? Well, here's what we could say. F of x is equal to, here's the general format we use. Whatever is inside of the absolute value signs, that's what we write as our first condition. So that is greater than or equal to 0. So in this case, inside of our absolute value signs, we have the expression x plus 5. So as our first condition, we're going to say when x plus 5 is greater than or equal to 0, we just return x, which is whatever is inside of the absolute value signs. So in this case, we're just returning x plus 5. So this will be our first condition. And then we say, whatever is inside of the absolute value signs, we're going to say that's less than 0. So that's our second condition. So in other words, when x plus 5 is less than 0. So let's write that right here. When x plus 5 is less than 0, we just return the negative version of whatever was inside the absolute value signs. In other words, we're going to return the negative version of x plus 5. So we could write that as negative x plus 5. Now the last step is when we're writing these piecewise functions, when we have conditions like this, we want to have x all by itself when we're writing these conditions. So we need to solve for x for both of these inequalities. So here's how we could do that. We could say, let's rewrite this as f of x is equal to, we have x plus 5 when, notice that if we subtract a 5 from each side right here, we would get x is greater than or equal to a negative 5. So x is greater than or equal to negative 5. So that's our first condition. And now down here, we can distribute this negative sign to these parentheses. So we get negative x minus 5. So let's write that right here. Negative x minus 5. And again, we're going to solve for x for this inequality. So if we subtract a 5 from each side, we get x is less than 0 minus 5 is negative 5. So we'll say x is less than negative 5. So this is going to be our final answer. All right, let's try one more example. Let's say we have the function f of x is equal to 3 times the absolute value of x minus 2 plus 4. How could we rewrite this absolute value equation as a piecewise function? Well, here's what it would look like. We could say f of x is equal to, the first condition will be, remember, whatever is inside the absolute value signs, we're going to say that's greater than or equal to 0. So in this case, we have an x minus 2 inside the absolute value sign. So our first condition will be when x minus 2 is greater than or equal to 0. Now, when this condition is true, remember, we just return the positive version of whatever was inside the absolute value signs. So in this case, we're just going to return a 3 times x minus 2 plus 4. Now, our second condition is going to be when x minus 2 is less than 0. So remember, for this second condition, we're returning the negative version of whatever we put in the absolute value signs. So instead of returning an x minus 2, we're going to return a negative x minus 2. So here's how we write that. 3 times negative x minus 2. And then we have plus 4. So these are our two conditions. All we have to do now is just simplify it a little bit. So let's say, so to simplify this first condition here, we can distribute this 3 into the parentheses, and we'll get 3x minus 3 times 2 is 6 plus 4. So here we have a minus 6 plus 4, that's just minus 2. So let's write that, minus 2. And our condition is when x minus 2 is greater than or equal to 0. But remember we said we want x to be all by itself here. So we'll notice if we add a 2 to each side, we can get x is greater than or equal to 0 plus 2 is just 2. And now for this second condition, if we distribute this negative sign into the parentheses, we get negative x plus 2. And then we have to multiply this by this 3 out here. So we get 3 times negative x, so that's negative 3x. And then we have 3 times 2 is 6. So a positive 6 plus 4, that will be plus 10. And then lastly, our condition will be, we want x to be all by itself, so we could just add a 2 to each side. So we would get x is less than 2. So this is our final answer on this one. So those were just a few different examples of how to write an absolute value as a piecewise function.